at a method that we could use to simplify a 3D polynomial expression. So you're going to use this, of course, to sketch the cubic function, right? So you're going to use this method to sketch the cubic function. Now this method is called the synthetic division. So it is used to divide polynomials, but in this case we'll use it to factorize or find the values of x, or rather the x-intercept on a cubic function, right? I'll do another separate video on explaining the synthetic division to divide polynomials or rational functions, but in this case you want to solve the x-intercept of a cubic function. Okay, so let us say you have some cubic function fx equal to negative 2x cubed plus 5x squared plus 4x minus 3. So some people wouldn't know how to factorize this expression here, so there's what we call a synthetic division, right? You know, factorizing is for grade 8 and 9, so probably most of you forgotten and do not have time to go back. So we do have what we call the synthetic division that will help us to make our life much easier. So so basically your teacher would have told you that, okay, you have to find a number that will make a value of x that will make this expression equal to 0, and then they will say, well, that value of x is mostly in the range negative 3 to 3, right? And then you will have to then check negative 3. If you plug in negative 3 in place of x, then will it give you the 0? If you plug in negative 2, will it give you 0? If you plug in negative 1, and so on, right, until to 3. Of course, if they do not give you 0, then you check others, right? But in most cases it will be from negative 3 to positive 3 in that case. Okay, so in this case we have this function here, right? Now let's check the f negative 3. Let's start from negative 3. Well, if you plug in negative 3 into our function in the value of x, what do we get? Let us see. So you'll have negative 2 times negative 3 cubed. Make sure to use your brackets, plus 5 times negative 3 squared plus 4 times negative 3 minus 3. Well, there we get 84, right? We get 84, and if we plug in negative 2, what do we get? Well, let us see. Negative 2, let us see, negative 2, well, we get 25, right? And then if you plug in negative 1, let's check negative 1, negative 1. Okay, so in that case, when I plug in negative 1, then I get 0. So what does that mean? Well, that means that in that case x equal to negative 1 is a factor. In this case is the factor of this polynomial. So if you solve here, right, if you transpose the negative 1 to the left hand side, we'll have x plus 1 is equal to 0, right? So meaning that x plus 1 times some function that will give you this expression will give us 0, because because this is a factor of this function here, right? So if you multiply the 2, if that is 0, then that will give us 0, right? So that means that, well, this is a factor of that. So meaning if we can divide this thing here, if you can divide that by that, then you will not get a remainder in that case. So meaning this here is our factor, right? It's a factor of this 3D polynomial function. Okay, so in that case, what do we do? Well, if you know the synthetic division, right? Let's look at some equation. So a 3D polynomial is given as fx is equal to a x cubed plus bx squared plus cx plus d, right? This is a 3D polynomial. Now let's say we figured out that the factor here, right, the factor here is, let's say, is x plus 1, or rather x plus, let's say, a. X plus a is equal to 0. So that means that x in that case is equal to negative a, right? So in this case I could say, well, negative a, and then I draw a line. Oh my goodness. Okay, so if I'll draw a line like that, so this is how you use a synthetic division, and then you will write the coefficient of all these are the 3D polynomials. So in this case you have a, and then you have b, the coefficient of x. Well, this one here, remember this is x raised to the power 0. The coefficient of x here is c, the coefficient of x there is d, right? And what you do is you drop down the a, and then you say, well, a times so what we're going to do is we'll say, well, this here times that, and then you put it here, right? So that times that will give us negative a squared, and then you basically add these two, right? You add those two, that will be b minus a squared, and then that times that, it will be there, of course, it will be negative a times b minus a squared, right? Then you drop that down, right? You drop that down. So you add these two, right? Here you add these two, then the answer that you get there after adding these two, you multiply it with that, and then you put it there, and then you add these two. So if that is it is indeed the common, or rather the factor of this polynomial function, then you should get the your remainder in 0, right? Let us look at this example here. Let us look at this example. This sounds like complicated because I can't explain it. Can't explain it using these variables. So let's look at some numbers, right? Remember here we said the first thing that you do is you first find the a value that will make this whole expression here equal to 0. And we said that, what happened? Okay, we said that, okay, we said that the expression that will make that we said that a value of x that will make this this equation here equal to 0 is x is equal to negative 1. Okay, so that means that in that case we said you transpose the 1, and hence we'll have x plus 1 is equal to 0, right? So in this case what you can do, well, you can say, well, it didn't have to transpose that, right? So you can just put the negative 1 here on the side, and then you draw down a line, then you write down the coefficient of these the coefficient here of x, right? This is negative 2, this is 5, this is 4, and this is negative 3. So it will be negative 2, 5, 4, and negative 3. Make sure you write them in order, right? Make sure you write them in order, and then what you do is you drop down the negative 2, and then you say, well, negative 2 times negative 1, that is 2, right? Negative 2 times negative 1, that is 2, and then you add these two, right? You're gonna add these two, that will give you 7 at least. Yeah, that will give you 7, and then that times that, right? Whatever answer you get there, you times it with that, and then 7 times negative 1, it is negative 7. You add these two, that will give you negative 3. That times that, that's positive 3. Remember, negative 3 times negative 1, that's positive 3. So that's positive 3. You add these, negative 3 plus 3, that's 0. So that means that, well, this here is a factor indeed. It's a common factor there. So remember I said I will go in depth and explain the synthetic division, the quotient and the remainder, but in this case we only need this part here. So the first one would be my x squared, this one here will be my x, and this one will be my the value of c, or rather the constant, and hence in that case it will be, remember we said that x plus 1, that case is equal to 0, so meaning x plus 1 in this case here, and then you will have this one is 2x squared, and then plus 7x, and then minus 3, which is equal to 0. So remember in this case they'll ask you to find, rather you have to find the x-intercept, right? So to find the x-intercept, you let my y equal to 0, and hence here you have 0, right? And hence here you have 0, and then this one you can factorize easily, right? You can factorize that easily by using quadratic equation, you can just factorize that easy. So you will have x plus 1, and then you use these two brackets. Here you have negative 2x, here you have x, so the factors of 3, so that's 3, that will give you 6, right? If you put 3 and 1 here, and then you notice that this here is a positive, right? So if I do this, can that work? Let us see. So that times that, that's x, that times that, that's positive, so it's positive 6x, and then if you add, they'll give you the 7x that you want, so meaning that could work, and hence you would substitute, right? So here my intercept in that case would be x is equal to negative 1, you will have x is equal to a half, right? And you'll also have x is equal to 3 as well. So this is how you can use a synthetic division. Okay, let us look at another example, just to make sure that you understand. Let's look at some example. So let's say you have g x is equal to x cubed minus 12x and then minus 16, right? Go ahead and solve, or rather find the x-intercept, right? Find the x-intercept of this 3D polynomial. Okay, so the first thing that you have to do is basically find the value of x that will make the function equal to 0 from negative 3 to positive 3, right? So starting from negative 3, so you put in negative 3, and then let's see what we get when you put in negative 3. Make sure you use the brackets. So negative 3 raised to the power 3 minus 12 times negative 3, and then minus 16, well, that gives us negative 7, so that ain't the one. So you check negative 2, let's click in negative 2 and see whether it will give us that 0. Yep, negative 2 does give us the 0, so that means that we will be using x is equal to negative 2. Okay, so now that we know which x value we'll be using, you draw your box, or rather not the box, but you draw this thing here, and then you're gonna write down your coefficient. Well, here it's 1, the coefficient of x is 1. The coefficient, remember, you have to go step by step. So you start with x cubed, and then you follow x squared, then x, and then x raised to the power 0. So in this case x cubed is 1, x squared, we do not have x squared, so meaning x squared in that case will be 0, so you have 0 there, and then x is negative 12, so this is negative 12. Remember, you're taking the coefficient of these values, and then the and then my x0, and then in that case is negative 16, right? And then what you're going to do is going to drop down the 1, then you say 1 times negative 2, that's negative 2, you add these two, that will give me negative 2, negative 2 times negative 2, that's 4, you add these two, that will give us negative 6, not 6, negative 8, and then that times that is negative or rather positive 16. because negative times negative, that will give us positive. If you add negative 16 plus 16, that will give us 0. So that means that this was correct. So in this case here, I know that this part here is my x squared, this part here is my x, and this one is my constant, and hence here I can solve. I can say, well, I can bring the negative 2 the inside, and hence if you transpose the negative 2, it will be positive. Then you say, well, this is equal to 0. If we have x plus 2, and then this part here, which is x squared minus 2x minus 8, which is equal to 0. Remember, whenever you're solving the x-intercept, you let my y equal to 0. Therefore, my y in this case here is equal to 0, right? And then you can just solve. We know how to factorize the 2D, in that case, polynomial, right? So what are the 2 degree polynomial? So in this case, you have x plus 2. You know how to factorize this to be x, x, and then this one will be 4 and 2, and then negative and positive, right? Therefore you will have your x values: x equal to negative 2, x equal to 4, and x is equal to negative 2, right? So this is how we could use the synthetic division to find the x-intercept of a cubic function. I hope that makes sense. You will want to memorize this formula here, or the way I use it, and try to do more examples. Use more examples. And yeah, on another video we'll be looking at how to sketch the cubic function, right? How to sketch a cubic function. And yeah, I'll catch you on another one.